Hi everyone, this video presents the solution to example 15 on rotated vessels, and this is the last example. A 75 mm diameter pipe 2 meters long is just filled with oil with specific gravity point A22 and then capped. Placed in a horizontal position, it is rotated at 27.5 radians per second about a vertical axis 0.5 meter away from one end. What is the pressure in kilopascals at the far end of the pipe? What is the pressure at the near end of the pipe? And what is the pressure at the midpoint of the pipe? So to help analyze this problem, let's draw the figure first. We have a pipe which is 2 meters long, capped at one end. There's no mentioned pressure initially, so it is assumed to be zero. Then it is rotated about this one end, 0.5 meter from one end. So therefore, it is 2.5 meters. The far end is 2.5 meters. So when rotated about this axis, the imaginary parabolic surface should intersect this vertical axis at its vertex, and it should pass through points of zero pressure or equal pressure. So it passes through the near end as shown. Then we will call the height or depth from the zero surface to the far end as HF. Then from the near end to the vertex as H1, far end surface to the vertex as H2. So let's compute these distances so that HF is H2 minus H1. So H2 is gamma 27.5 square radius square or distance square 2.5 square over 2g. So H sub 2 is 240.9 meters. H1 is 27.5 square, 0.5 square divided by 19.62 or 2g, so H1 is 9.636 meters. So from here we can now compute HF. Therefore, the pressure at the far end is equal to specific weight 0.822 times 9.81 times HF, which is the difference between H2 and H1. So 0.822 times 9.81 times the quantity 240.9 minus 9.636. So the pressure at the far end is equal to 1865 kilopascals. Then for 15.2, because the surface of equal pressure equal to zero passes through the near end, must pass through the near end because the initial pressure is zero there. Pressure at the near end is 0 kilopascal. Then finally, at the midpoint, we will call the height as, we will call that H3, and the net height of the point on the midpoint to the zero pressure is the difference HM, the difference between H3 and H1. So the pressure at the midpoint is equal to 0.822 times 9.81 times quantity H3 minus H1. So H3 is omega squared with 7.5 squared. The distance is 1.5, so 1.5 squared over 2g. So H sub 3 is 86.73 meters. So pressure at the midpoint is 0.822 times 9.81 times quantity 86.73 minus 9.636. So pressure at the midpoint is 621.7 kilopascals. So that's it for this video.